Hi, everybody. Okay, we are going to do a quick review of the properties we found with parallelograms, and then we'll look at the special parallelogram, so rhombus, rectangle, and square, and find some new properties that exist with those. So the first thing we want to do, just on a piece of scratch paper or somewhere where you can squish this in your notes, let's do a quick review of what we found in a parallelogram. So go ahead and sketch a parallelogram. Oh, and let me mention as we're going through this, the nice thing about having a video is if you want to pause, rewind, play something again, come back to it, later and double check something, please keep in mind that you can do that throughout. Okay, so this is what we've found so far in a parallelogram. We know opposite sides obviously are parallel, hence the definition or the term parallelogram. The opposite sides are also congruent. Just watch how you're putting tick marks on there. We need a different number of tick marks on there. Okay. We also, hang on one second here. I want to make sure I'm actually recording. Guys, I just made a video for 20 minutes and then it didn't save. So I'm just making sure that this is actually recording. Okay, it is recording. Okay, moving on. Okay, so we also found that the opposite angles are congruent. Different, though, from one another, those pairs. So put, again, a different number of tick marks on there. And because we've got a bunch of parallel lines, we also have consecutive angles that are supplementary. Now, remember what that means is like any two kind of next to each other, right? These two would add to 180 because they're just same side interior. These two would also add to 180. So would kind of the two on the left. So would the two on the top. All of those pairs are what we consider consecutive angles. They are supplementary. And then the last piece we found, so if we put the diagonals in there, first of all, they are not congruent, but what they are is, or what they do is bisect each other. So watch how you're marking this. I'm going to put 3 and 3 markings here to show that this one gets cut in half, and then 4 and 4. Okay, I don't want to put 3 everywhere because then that would imply that the diagonals were congruent to begin with, which they are not. Okay. Now, what we're going to look at today, rhombus, rectangle, and square, those are all special kinds of parallelograms. So everything that we spent, yesterday's lesson on discovering with a parallelogram, all of these properties apply to a rhombus, a rectangle, and square. We're just going to see if there's anything else like new out there that we haven't seen yet. All right. So go ahead and find in your note packet. This is lesson 5.6, page 17. It should say 5.6 at the top of yours. Okay, so page 17. And we are first going to look at a rhombus. So I like their instructions here, like what you're doing, but this is kind of silly. They want you to like just figure out what will be created. Our goal is to create a rhombus here, but we're going to use their little method, their kind of straight edge method to get these sets of parallel lines. Okay, so let's put this up here. Just enlarge it a little bit so it's not distracting you the whole time. Or me. Okay, so we're going to follow along with their instructions here. And we're going to use a double-edged straight edge, also known as a ruler, to draw 2 pairs of parallel lines that intersect each other. Okay, so use your ruler. Go ahead and lay that down. And we're going to trace either side of it, both sides of it, before we move that ruler again. So I'm going to lay it down. I'm going to leave it here until I have traced both sides. So 1, 2. Can you see both Sharpie lines here on mine? Before I move my ruler, I'm going to trace both sides. Now, I'm going to turn my ruler. The only thing you're not allowed to do is make this perpendicular. I do not want to end up with a square. So I'm just going to put it at kind of a different angle here. There's no real rule about how to angle it, just can't be perpendicular. I'm going to repeat the same exact process. Lay my ruler down, trace both sides. Okay, you see my 2 Sharpie markings there. And when I pick this up, I have obviously a parallelogram because I've got 2 sets of parallel sides. But because I used like the same ruler both times and those distances are all the same, everything's nice and equidistant. These lengths here would all be the same. That makes it a rhombus. Okay, so this first conjecture on page 17, I'm not so concerned about this, but it is a nice reminder of like a cool way to get a rhombus. All right, so it says if two parallel lines are intersected by a second pair that are the same distance apart as the first, meaning you use the same ruler both times, then the parallelogram that is formed is a rhombus. Okay. Now, let me just remind you right off the bat that a rhombus is a parallelogram. So everything we just discussed on this previous diagram applies. I could put, in fact, we could put a little bit on here. I could at least put the parallel markings on here. I could mark my opposite angles congruent, but I'm going to hold off on those for just a second because I want to do something when the diagonals are thrown in there. The diagonals also bisect each other, but again, I just want to hold off on that for 1 second. Let's do a little bit of investigating with them first. All right, so go ahead and turn to page 18 now. We are going to draw in both diagonals of the rhombus that we've created. If you want to erase all this extra stuff around here, by the way, you're more than welcome to do that. I can't, I used a Sharpie. So go ahead and put your diagonals in there. There's one. And here's two. And I know I am right away like really tempted to mark something on here. I really want to put right angle markings on here, but let's just confirm that those are actually 90 degrees. So you could kind of go the traditional route and measure with a protractor, but because we have patty paper, this is kind of a neat way to do this. Like these angles right here, I'm putting the little dots. I know they're a linear pair, right? They obviously make up this straight line together. But if I fold this rhombus in half along that diagonal, I can also see, I don't know if you could see where my teeny tiny little dots are here, that those angles are congruent. So if they're congruent and they have to add to 180, that means they have to be 90 and 90. So just sort of a different way to get to that perpendicular marking. So the diagonals are perpendicular. That is new to a rhombus. Okay, let's fill out this first part of the conjecture here. Oh, by the way, they also still bisect each other. That's not new. We're stealing that from a parallelogram, but it's worth marking on here. So I'm going to put 2 and 2 tick marks, and then 3 and 3. The diagonals are still not congruent, so I want to put a different number of tick marks on there. Okay, so this conjecture right here, we're going to add 2 pieces to this. The diagonals of a rhombus are perpendicular. That's the new thing to know. And they bisect each other. That's not really new. That's just because a rhombus is a parallelogram. Okay, one more thing to discover with these diagonals here, and you may have noticed or not by now what's going on here. It says the diagonals in the sides of the rhombus, if you look kind of near each vertex, we've got 2 angles now, right? These diagonals break those big angles into 2 parts. It says fold your patty paper to compare each pair of angles. So maybe just focus your eyes on like the 2 that are on the top of my screen. You can do this on yours as well. If I fold again along that diagonal, I can tell that those 2 angles that are here kind of turned into 1 angle, right? Because they're the exact same size. They overlap each other. Similarly down here. If I fold along the other diagonal, so fold the other way, I can see that again, these 2 angles kind of at the vertices are the exact same size. They are congruent as well. So not only do the diagonals bisect each other, they also bisect the angles. And remember, the opposite angles are congruent to begin with. So when I mark these angles here, I'm going to put 1, 1, 1, and 1. Why is my thing so yellow? I don't know why that lighting looks like that. Okay, and then 2, 2, 2, and 2. Okay. Oh, that's kind of hard to look at. Oh, that's not any better. Okay, there we go. It's a little better. Okay, so that's the last little new piece for a rhombus here. We're going to state that the diagonals of a rhombus bisect the angles of the rhombus. Right? Now you've got a little bit of room on the bottom here, so let's go ahead and sketch a rhombus and see if we can get all of these markings on there. So we've got it on the patty paper, but I'd like to have an official one in our notes. I'm going to try to use my parallelogram tool and just make it look as close to a rhombus as I can. What's happening here? There we go. Does that look rhombus-like to you? Close enough. Okay. All right, so go ahead and just sketch a rhombus. And let's see what we can fill in here. Okay, so we're going to sort of just run down the list. We know opposite sides are parallel. It's a parallelogram. Opposite sides are congruent, but not just that. All four sides are congruent. A rhombus is an equilateral quadrilateral. The opposite angles are congruent, and that supplementary thing is still happening, but I'm going to wait and mark that a little bit differently once we have the diagonals in there. So go ahead and put the diagonals in. Ugh, now that I'm looking at this doesn't look super rhombus-like. I should have shifted that. You get the idea. Okay, so the first thing, and this is not the best picture, but these should be, whoops, little right angles here. There we go. And they bisect each other still. So 2 and 2, 3 and 3, but they're not congruent, remember. And then the new thing here, these opposite angles are bisected, or excuse me, the opposite angles are congruent, and now all the angles are bisected. So I'm going to mark 1 and 1 and 1 and 1, and then 2, 2, 2, and 2. I think that's everything that we have there. Okay, now something to note, and this might be helpful when you're looking for some missing measures here. We really just have, I really wish that picture was better. I wonder if I can, hang on, let me try to do something here real quick. I don't know if this is going to work or not, but I'm going to try to make it look a little more rhombus-like if I can. Let me stretch it. No, it's just going to let me enlarge it in or out. It's not going to. I was trying to distort it a little bit so it actually looked more like a rhombus. Anyways, so you get 4. They should be 4 congruent right triangles that you get out of this. I know we thought about that similar concept in a kite, right? We had 2 sets of right triangles that were congruent. So if you look at this one, that might be more helpful, right? You can see 4 nice little congruent right triangles there. Think about that as you're filling in some missing measures. Okay, moving on. Next part here. Oh, and by the way, if you need to pause, rewind, go back, double check anything, by all means, feel free to do that. Next one here, we're going to draw, using just the grid lines and a straight edge, go ahead and draw a nice big rectangle. I'm going to use my little straight edge tool. And remember, a rectangle is also a parallelogram. So all of those parallelogram properties apply. All parallelogram properties apply. Okay, like opposite sides are parallel, opposite sides are congruent. What's new, just based on the definition of a rectangle, we know that all the angles are the same, and we can specific than that. They're all 90 degrees. If you want to throw little right angle boxes in there, you could. So notice the opposite angles are still congruent. That still fits our parallelogram property. And all of those consecutive sides or consecutive angles are still supplementary. They're just 90 and 90, right? We've got lots of 90 and 90 pairs going around there. What's new with a rectangle, if we put the diagonals in there, and I don't know about you, but as I'm drawing these, like I can kind of feel that they are congruent to each other. So go ahead and measure these 2 diagonals. This is the first time we've seen that they are actually congruent to each other. So I'm going to mark, and they still bisect each other, right? Because it's still a parallelogram. So I'm going to put 1, 2, 3, 3, 3, and 3 tick marks everywhere. Now, they are not perpendicular. Please don't put right angle boxes here. If yours looks a little more square-like, you might be tempted to put right angles here. And it also does not bisect the angles. Again, if yours is a little bit like short and fat compared to mine's like a little bit longer, it might be tempting to mark them that way. But this is really all that's going on with the diagonals here. Okay, so drawing both diagonals, and we're going to say here at the bottom, the diagonals of a rectangle are congruent. And still, because it's a parallelogram, they still bisect each other. Okay, we're just stealing that again from the parallelogram properties. Okay, now the last piece of this is basically like just to put all of this together. Go ahead and turn the page. We're on page 20 now. This is what happens if you combine the properties of a rectangle and a rhombus. You get a square, right? Sometimes we call that a regular quadrilateral, where the sides and angles are all congruent. And we've talked about it in terms of, square. Yes, it's a rhombus. Yes, it's a rectangle. You just have to make sure that the sides and angles are the same. Okay. Now remember, it's also a parallelogram. So basically everything we've gone through so far, we're going to put all of that together in one diagram and fill out all the pieces, all the properties of a square. Let's emphasize here or reiterate what's going on with the diagonals, and then we'll have a nice big diagram and everything is there. So here we go. The diagonals of a square are perpendicular, steals that from a rhombus, congruent, steals that from a rectangle. They bisect each other, steals that from just like the generic parallelogram, and they bisect the angles of the square. Steals that from a rhombus also. So as we put in those diagonals, we want to think about like, how do I mark the diagram to show all of these things? All right, go ahead and sketch a nice big square on your page. And sketch is fine. Just try to make it as square-like as you can. Use my little square tool here. Okay, so here we go. A square is or has parallel sides. Opposite sides are parallel. Opposite sides are congruent, and more than that, all four sides are congruent. Remember, it steals that from a rhombus. Has that in common with a rhombus. That's why a square is considered a rhombus. I kind of stopped right here. I could say that this is a square or a rhombus. I don't know until I now mark the angles. Although I'm going to hold off on the angles because I want to put something different than 90 degrees there. Now, once we put the diagonals in, we've got all sorts of things we can mark now. So first of all, the diagonals are perpendicular, congruent, and they bisect each other. So I'm going to use kind of these two ideas together to put the proper markings on there. I'm going to put 2, 2, 2, and 2. That shows that the full diagonals were congruent to begin with. So now all the halves are congruent. Okay. And they bisect the angles. Now remember, these were initially 90-degree angles, and you could put that on there, but I think what maybe is more helpful here, I'm going to show that really all 8 of these angles are the same. I'm going to put 1 tick mark on each of them. And if they were to begin with, think about how big those are individually. Those are each 45-degree angles, okay? Just like a rhombus, we also have 4 congruent right triangles we could look at. That may help you kind of fill in some missing pieces. Okay, one more time if you need to pause, rewind, go back, fill anything in. I'll also post these notes a little bit later on the classroom so you can make sure you have everything complete. But make sure that they are complete because then tomorrow we'll use these notes to find a bunch of missing measures in all these different parallelograms. All right, everybody, thanks for sticking with me. Let's see if I can figure out how to stop this now. Okay, I will see you later.